Your due now is on the board. Take 2 minutes to complete this on your handout. So at this point, I would set a timer and walk around. It would be up to students to read the prompt and then respond to it in writing silently. Afterwards, we would follow up with a turn and talk, during which point I would try to overhear a pair of students talking about how the scenario on the left with the leaking tank and the straight line is showing constant change, whereas the scenario on the right showing distance over time is showing acceleration. And then we would go over our objective for today, which is we will define and find the constant of proportionality to describe ratio relationships using a graph or ratio table. So now, class, we're going to take a few notes. Constant means changing at the same rate. We've been talking about ratios, and we know that a ratio is a constant relationship. In a graph or ratio table, we can use an equation to define this rate of change as the constant of proportionality. And then in your notes, I'd like you to circle K. K is what we're going to use to represent the constant of proportionality. There's an equation, it's very important, I need you to add it. K equals Y over X. So if we have a graph, we know that Y is simply the variable that is graphed on the Y axis. And then if we are looking at the X axis, what variable is that? Many, many times it's going to be time. And so basically K is going to show how something changes the Y over a given amount of time or a given number of attempts over that X. So let's look at an example here. I'm going to model for you how to read a graph and then how to read a ratio table. Both of these are showing the rate at which water leaks from a tank over time. So it's the same data, just two different forms. Read this with me. It says Shelley works for Anne. She notices that the water volume of one of the tanks is decreasing. So we know that D means down. So decreasing means it is going down, which indicates a leak. The graph and table above show between the amount of water lost in gallons and the amount of elapsed time in minutes. A. Write several ordered pairs from the graph or table and explain what each ordered pair means in the context of this data. For the purposes of this video, teachers, I'm just going to model one ordered pair for the sake of your time. All right, so class, I'm looking back at my graph, and I know that I want to find a point that has a clean intersection where I can clearly read the X and the Y coordinates. So I'm looking at this dot, and I see that the X is 4 minutes, and the Y is 3 gallons. So I would write that as 4, 3. Well, then I want to think to myself, well, what does that actually mean, this 4, 3? This means that in 4 minutes, the tank loses 3 gallons. That same information is indicated here in my table. Okay, so now that we've thought about this data and what it means, let's go to B. Write several equations that would relate the number of gallons lost to the time elapsed. Okay, so for this, we need to consider the number of gallons lost, and I'm going to call this G, to the time elapsed, which I'm going to call T. So if I'm looking back at my data, I know that my number of gallons lost is what's changing over my time. So I'm going to start with that, my G, what is on my y-axis. And I know that my G is going to equal my change. If I look at in 4 minutes, the tank loses 3 gallons. The way that I can write this is 3 over 4. So G is going to be 3 over 4T. How do I check this? I can plug in a G and a T and see if that actually works. So I know that my equation, 4 represented my T, 3 represented my G. So I can say 3 equals 3 over 4 times 4. Okay, let's double check that. 3 equals 3 times 4 is 12 over 4. 3 equals 12 divided by 4, which is 3 equals 3. That works. So I can use this same pattern. I'm thinking about my gallons and my time and my change to write as many equations as I'd like for additional points. And that's probably something we would do as a class if this were actual. C, determine the constant of proportionality and explain what it means in this situation. So I'm going to rewrite my equation. I know that K, my constant of proportionality, is going to equal my Y over my X. And I know that my first ordered pair that we wrote down for my constant of proportionality, if I go back here to my ordered pair, my Y was 3, my X was 4. So I know that my constant of proportionality is 3 over 4. Now I have to explain, what does that actually mean? So what this means is, we'll just write this as a sentence, the constant of proportionality is 3 over 4, which means that the tank loses 3 gallons every 4 minutes. Or if we really wanted to make this a unit rate type of constant of proportionality, what I could do is, I'm trying to get this 4 to be a 1 so that I know, well, how much is it losing in 1 minute? So what I could do to both sides here is I could divide by 4 to make sure that my denominator is a 1, so I'm getting a unit rate. And what that's going to give me is 3/4 over 1. So basically this means that it's going to lose 3/4 of a gallon every minute. So that's another way of saying my same constant of proportionality. So in my sentence, I can say, or the tank loses 3/4 of a gallon every minute. Okay, now that we've done some together, you're going to partner up and you're going to examine a different data set, but use the same exact questions to discuss the constant of proportionality. You have 10 minutes, begin.